developer with VMware. I work on Spring Cloud tasks, Spring Cloud data flow, and when Oleg lets me even Spring Cloud stream, when Mahmoud says, if I have to, I work on Spring Batch. When I don't do that, I am also on the board of directors of Devnexus and on the board of AJUC. Have we been caffeinated after lunch? Okay, you just had a cookie. Did you recaffeinate after the cookie? Raise your hand. Okay, those that did not raise your hand, go get caffeine, come back in. All right, folks, I'm going to introduce my esteemed colleague, Felipe. Tell them about yourself.
Hey, thank you guys. Thank you for coming. And, I'm going to ask you, actually, if you Twitter and do the hashtag Devnexus, you can get one of these books. I wrote this book like a year and a half ago, everything about Spring Cloud Data Flow. So the first two guys that actually come and show us the hashtag, it will have this particular book. All right, so my name is Felipe Gutierrez. I part of the Spring Academy team. I'm creating content for you so you can get to know Spring. And I'm happy to be here actually starting with this particular talk. And let's start with the agenda, right? So first of all, we're gonna get part of our business case, so we are in sync up. Of course, we're gonna do a small demo very quickly so we have the time to actually go through the whole thing. Then we're gonna get into the microservice solution. That POC that we're gonna do, we're gonna convert that into a microservice, and of course, we are going to have the demo as well. Then Mr. Glenn is gonna take us with Spring Modulith, start doing some of the concepts. Of course, some definitions there. I hope you don't get bored. That's why we ask you to drink the coffee, right? That was the case. Then, of course, we are going to use a Spring Modulith to refactor our code, right? The microservices now using a Spring Modulith. And of course, we are going to do some testing. This is one of the best features that I found interesting in Spring Modulith. Of course, we're gonna get with the summary. At the very end, some questions and answers, right? So let's get this started. So one of the things I want to tell you is that Glenn has this particular hobby. He likes to do kayaking, right? So he is awesome on kayaking. So something that he actually asked me to do is, hey Felipe, what about if we start with an application that allows me to actually go ahead and get into this particular service from the USGS and then collect everything that I need to know about the creeks and the water levels so I can do kayaking, right? So that's actually something that we are going to do today. So something that I want you to actually pay attention is these three concepts, these three modules. First of all, one is that we are going to collect the data, right, from USGS. Then we are going to do a transformation, and after that, we are going to kind of massage those data and then put it into a console, right? So let's jump into a demo. So I'm going to actually switch over here, and I'm going to show you this particular application. So I have this guy right here. So don't worry, I'm gonna zoom out. So something that I'm, zoom in. So practically here I have the first thing we're gonna do is actually call this application runner. So if you're familiar already with the Spring Boot, you already know that if you want to execute a particular code after your application is ready to run, you normally come up with an application runner. So what we are doing here is practically using the template, REST template, get for object. We are going to the USGS and then collect the data. Then something that I'm doing is going into the transformer, right? So I'm transforming this, and take a look that right now this function has, I'm using functions, and in this case we are getting a string and we are retrieving or we are sending back a list of creek measurement, a value object there. And then after that, then I go and just do, print out everything in the console. So something that I want to show you right now is just run this application. Again, very simple, 3 modules. Go to the GS, go actually and do the transformation and then add this particular into the console. So I'm gonna zoom in over here, and as you can see, when you are ready to go to these creeks, right? So that's simple. That's what we want to show you over here. Very good. So next, something again, how can I convert those three things or these three steps into a microservice solution? So the first thing, of course, is going into this, retrieve the data from the USGS. Then, of course, that transformation, that particular function is going to become its own microservice. And then, of course, we are going to calculate if the stream is okay. Now we're going to write that into the console. So practically it's the same thing. What I did was just to split that into a separated microservice. Then something that he actually asked me, hey, what about, Felipe, if we actually have another consumer and then grab that information and save it directly into a data store? Of course, we did that. And then, he wanted to get fancy. So, hey, what about if I receive some alerts in my phone saying like, hey, Glenn, you can do kayaking? Of course, we added this again. Now, let me tell you about these individual microservices. We use Spring Cloud Stream. The Spring Cloud Stream is one of the, and this is my personal opinion here, but I think this is one of the best projects from the Spring team. Why? Because it allows you to do the communication between one to other microservice without you knowing the technology, meaning that you can swap binders. And in this case, or in this example that we're gonna see, we're using RabbitMQ. Of course, in the Quick Transformer, going to every single one of the consumers, we're using RabbitMQ as well. And again, one of the coolest features here is that you can swap these binders, these channels, these message brokers, without you changing the code, without knowing the underlying technology about messaging. So what happens if you want to have your Quick producer using NATs, right? Just a message broker going into a Quick Transformer. You don't need to hire somebody who knows that. Practically just swap that into your palm, and practically that is being used. And what about the other? What about if you start using Kafka? Probably, right? So this is, again, one of the cool things that you can see over here. Now, let me show you the code, right? So let me show you how easy it is for this microservice. So this is our first microservice, right? The one who actually goes and collects the USGS. Very simple. And as you can see, we're using a supplier right here. The supplier is going to retrieve or is going to send the string over the wire. Then we have our transformer. Take a look again. It was just a copy paste on that, right? We get the string, and now we are sending back a list of quick measurements. And of course, just very simple, just the login of the consumer. That simple is how you can create microservices using, of course, Spring Cloud Stream. And of course, we are using RabbitMQ. So let me show you this demo so you can take a look what is happening behind the scenes. So over here, on your left, you have the Quick consumer, you have the other consumer that has the repository, you have the producer, and you have the transformer. So what I did actually was, for each one of these microservices, I create a Docker image out of it, right? So the thing is, I want to show you over here is your Docker Compose. This Docker Compose starts, first of all, with the services. Of course, I have the RabbitMQ. Then I have the persistence. I'm using MariaDB. Then I'm doing the Quick consumer. So this Quick consumer has not only the log, but also you can set a property to send alerts into your phone, right? And take a look. I'm saying, hey, Spring RabbitMQ host practically is going to use that binder. Then the transformer, and of course the Quick storage, and the last, the Quick producer. So let's actually go ahead and run this application. So I'm gonna do Docker Compose up, then I'm gonna go into my logs. Again, no worries, I'm going to zoom zoom in over here. And while this is happening, I want to show you, this is the RabbitMQ console, and then you're gonna see very soon the exchanges that are being created. So the Creek data, right, and the USGS data, and then of course my queues, and these queues, one is for the storage, one is for the log, and one is for the transformer. So as you can see, it's automatically, you don't need to worry about, hey, how can I gonna create these exchanges or queues inside RabbitMQ? No worries, this Spring Cloud Stream does that for you, right? So we go back over here into the logs. So practically I have this, so I'm sorry, Glenn, you cannot go to the Creek at Roswell, right? So that's what is happening. Very good. So with this, now I'm gonna pass the microphone to Glenn so he can start talking about some definitions.
Folks, what we just covered was actually it's a fantastic presentation, and Oleg's going to go into a lot more detail about what just the magic that happened with that with Spring Cloud Function and streams and how that fits together tomorrow. So please be sure to catch his talk. But now we're going to switch gears. We're going to do something pretty radical with that demo that we just showed. We're going to actually take that microservice architecture, which works, it's fantastic, and we're going to kind of put it right back into a monolith. Now, the thing I want us to focus on is as we go through this process, I'm not saying, oh, microservices aren't good. It really depends on what you want to do. So as we go through this process, you may not go that whole radical process of bringing all my apps back into a monolith, but you may say there's certain areas. Are we syncing over there pretty good? Okay. There might be certain areas where you may want to take some of your microservices and aggregate them together, but how can we do that in such a way that we can maintain the architecture of those of our application? So what we're going to introduce is something called Spring Modulith. As we begin this, I'm going to cheat. I'm going to read right off the definition, and we'll kind of cover it a little bit deeper. Spring Modulith is a Spring project that helps better structure Spring Boot 3 applications through modules and events. The project introduces new classes and annotations, but doesn't generate code. The whole idea behind Spring Modulith is this. It allows me to identify the modules within my application. Once I've identified those modules within my application, I can then establish the behavior of each module. I could specify what services my module will expose, but conversely, I can also be able to establish what, if I have like a module A and I have modules B, C, and D, we can go in and make sure that module A may only want to have access certain features of modules B and C. I'm given that level of control. Then, once I do that, how can I take and make sure that any code that I write follows and is, that the code that I write actually goes in and follows the module design that we specified, okay? And Spring Modules is going to offer us tests to actually validate the code to make sure our code actually works with that, that our code works with the module design. Also, Spring Modules also offers us the ability to go in and generate documentation for us. And then we're also going to talk about how we can actually create events such that modules can communicate with each other. So, when we talk about modularization, we're going to go back to what Nate Shooter will say is the 0th law of architecture. We want to have good modularization. What we want to have is, I'm going to probably disconnect this because we're still getting a little bit of, there we go. Let's try that again. Maybe that'll do better. There we go. If it doesn't have a hiccup, we'll figure it out. So what we want to be able to do is this, is actually focus on having modules that have not low cohesion and high coupling, but what? Low coupling and high cohesion. Meaning, if I make a change to module B, I don't want that change to be reflected heavily in modules A and C. Similarly, if I look at like a traditional kind of deployment where I have controllers, models, repositories, or services, if I make a significant change to user, what could happen is that by making a significant change to user, I have to touch every one of those packages. And that reflects as something that's going to have high coupling. But what I'd rather have is something that has low coupling. And that is where if I make a significant change to A, modules C and B will not have that much change. So it's just those basic practices. So if I were to maybe focus more on the domain and have a domain of orders, a domain of products and users, by doing that, a significant change of users is going to be contained within the user's package, or what we're going to refer as modules. Now, with any Spring project, they're going to have, especially if it's built off of boot or for boot, they're going to have a default set of behaviors of what we would say is good practices. So basically what it allows us to do is Spring Modulith will say, look, I'm going to look at your base package. And now when I look at your base package, I'm going to then look at the packages that are directly underneath, and those packages underneath will be our modules. So for example demo, we'll have orders module, we'll have the products module, also the users module. So with that being said, and knowing the default behavior of what Spring Modulith will do by saying, these will be the 3 modules that I'm going to identify. The one question that we commonly get, what if I have modules in a different place? Is there an override for that? Absolutely. You can specify your plan of what modules you want, and Spring Modulith will honor that. So the tools we'll be using today is Spring Boot and Spring Modulith. So I want to do something a little radical here, right? I want to take the microservice infrastructure I have here, which is BAFA. It is great. But maybe what I want to do is move this back into a monolith. Can I do that? Is it possible? So let's visit that. Well, the first thing I want to do is I want to visit each of the services and identify the modules, or better yet, the domains of my project. And so I want to make these domains my modules. So the first one we're going to look at is what's called the Creek Consumer Report. And the Creek Consumer Report is basically something that's going to just generate a log entry every 50, or produce a log. So this is primarily meant for our park service. So when I drive up to the park service, they want to know, okay, what creeks and rivers are in the park today that Glenn could go kayaking on. So that's going to become our park module, okay? Then we have where we receive an SMS message, and when I receive that SMS message, that's for what? The kayaker. I want to know what creeks I can go kayaking on. So in that case, and what service we're offering is we're going to get that SMS message, which is going to be sent to me telling me the conditions of the creeks or rivers that I go kayaking on. So I want that to be a kayaker module. Similarly, I have also the Creek Research, which is a consumer for database. That was meant for what? Research. So we're going to take that and create a research module. The other 2 services we have here, the Creek Producer and Creek Transformer, they have very strong knowledge of United States Geological Survey data. They know how to take that data and be able to translate that and give me something that's useful for me to know whether it's good for me to go kayaking or not. In that case, I want to create a USGS module. We're going to introduce a new module that's going to be called, can't even see my own screen, Water Advisor. And then the Water Advisor, its goal is to wake up every 15 seconds, retrieve data from the USGS module, and then emit messages to the other modules such that when I emit these messages to the modules can get these messages and take action on as they see fit. Now, the thing that I want us to cover is, and one of the questions is Glenn, that looks strangely like a microservice architecture. Do I need to do this? The answer is it's up to you. I can actually have this where I'm not emitting messages to these modules. I can actually make direct calls to the beans or services offered by those modules. It's up to you. So when I go through this, I want you to start thinking about your microservice architecture and say, how can maybe I take and consolidate some of my microservices, or the services in microservice architecture, maybe consolidate them into or aggregate them together. Is that possible? Or if I have a monolith that I already have out there, is there a monolith that I can go ahead and take that monolith and break that up into modules? And so we're going to be giving you a demo of that. So let's go here and go ahead and get our demo. So the thing that we're going to look at real quick is the following. If we go back to the original rules of defaults of how we bring up and identify the modules within a Spring Boot application, the first thing we're going to do is go to our base package, which is iospring.waterlevel. And remember, we had 5 services. We're going to start off, let's say 5 services, 5 modules. We're going to start off with 3 modules. It'll be Park, USGS, and Water Advisor. So let's dig in a little bit and go to our USGS module. In our USGS module, we have what's called the USGS service. And this is pretty much a copy and paste of what Felipe showed earlier. The only change that I made is I identified it as a service. And then with that service, I said, I want to go ahead and just have one method exposed. And that one method that is exposed is going to go out, grab the data from the USGS, and then return the status of the sensors that are coming, or the sensors that are on the rivers, and tell me for those sensors that are on that river whether that river is good for me to go kayaking or not. So that's all that is, and its best type of code is copy-paste, right? Y'all didn't argue like I expected you to. But the other thing that I wanted you also to be able to show is like for the USGS module, notice that for that module, remember, any package that's directly under the base directory or the base package are modules. So I'm going to start referring to Park, USGS, and Water Advisor as what? Modules. But under the USGS module, I have a USGS stream package. This is unique because what I want to talk about there real quick is that any package that's underneath a module will be considered to be only used by that module. This is pretty interesting because USGS stream data is really only used by the USGS service for now, but since I put it in a package underneath that module, I don't want to share it with the other modules. Okay? So the thing to remember, right? Real hell. Sound check, 1, 2. Did it come out? Sound check. Did it die?
Hold this for you.
Okay. Did it die? Sound check. There we go. All right, if it dies again, I'm going to take you up on that. So, if there's any other IOV problems, we'll all go out and have a cup of coffee. All right, so what we're going to do real quick is go ahead and talk about the USGS stream data here. It is used only by the USGS service, and by using this, I don't want this exposed to other objects. So the way that I do that is by putting USGS stream. Now, but the problem is, in order for that USGS service to use it, it has to be declared public. And when I compile it, what happens? It means that according to Java, I can use it in any of the other what is considered packages. But how do we enforce keeping it within that module? The other stream module is going to offer some unit test tools such that when I do my testing, it will tell me at that time, hey, you're trying to use maybe this USGS tool for a class we're not supposed to. It will demonstrate that in a little bit. So now we have our Water Advisor module. It has a water level service. And that water level service basically has I'm going to zoom out and back in here. Whoop, there we go. And the water level service, it basically takes in an application event listener, which is the default event listener that comes from Spring Cloud, from Spring. And it also takes an instance of what? That USGS service that comes in from the USGS module. And then it has 3 methods that are exposed. One is to get the status from sensors that we have for the USGS service. But also we send out and publish event messages. Again, using Spring's event messaging. And what we do is notice that if anything is marked with a green check, that means that the creek is good. Mike is dead. All right, there we go. So what we're going to do here is be able to say, look, that if it's got a green check, what we're going to do is we're going to take and return that back out and say, or I should say, we're going to emit that message. But then what we want to be able to do is also emit messages regardless of what the condition of the creeks are. And notice that the one that I want to emit, if they're only good, is alert status. But if they're regardless, I want to send out a stream data status. So with that being said,
Glenn, before
Yeah,
you,
please.
yeah, before you move around. So something that I want to share with you guys is that I don't know if you remember, I was telling you about microservices. They connect or they communicate between each other using a binder. And in this case, we were using RabbitMQ. So the thing here is that the new modules are going to communicate through application event listeners, through events. So that's kind of the change. Now, Glenn was talking about some of the data that is being stored just like that, right? So I don't know, Glenn, if you can go to the pom.xml, just very quickly go and we can actually talk about it. So I don't know, if you can, So if you take a look, we are including this JPA. And again, probably you already know because Spring Boot is opinionated. What it does is going to take a look into your class path. It's going to say, hey, you have JPA and you have the Spring module JPA. So every single event that you are sending, I'm going to save that into a data store. Practically, that is out of the box. So you don't need to worry about it. Practically wires everything up. Now, if you scroll down a little bit, Glenn, another important dependency I think you need to add here, it will be the test. The Spring Modulith provides this test framework that allows you to actually take a look into your architecture and do verification, do documentation, and do even more stuff. But I'm going to let Glenn to continue on this. Thank you, Glenn.
Okay. And thank you. So what we're going to do next is we're actually going to go to our water level scheduler. And from our water level scheduler, what we're going to do is to go ahead and create a scheduled here. Yeah, I will need your help. So, little do we know that Felipe was multi-talented. He can also hold mics really well. Thank you. So what we're going to do is we're going to go WLS in here. And what this allows us to do is to create a constructor that's going to take the water level service. From that water level service, we're going to have a scheduled event that's going to launch this method once every 15 seconds. So the first thing we want to do is do a string result, and we're going to go get that data. So we're going to have a water level service.get status for the default sensors we have. And if I could type, there we go. And then what we want to do is also be able to now emit these messages for what we get as a result back from the USGS data. So what we're going to do is do another water level service send alert, so we could send it for those sensor IDs for the result that we got back. And then we're going to also do it again for send it for a data notification for sensor IDs, comma space result. All right, now this is going to wake up every 15 seconds and it's going to send out events, and we want our other modules to pick up those events. So to do that, what we want to do is to actually zoom in and go to our park module here. And for our park module, what we want to do is have a listener. So we're going to zoom in on here on this listener. And what we want to do is to say, let's go ahead and say a void. We'll call it on. And then we'll have it listed for a stream data status. And we'll call it status. And what we're going to do is we're going to just have, we're going to do a log.info. We're just going to print that out to console. This will be for like our park service so they can get a result once every 15 seconds. And we're going to say status.getStatus. Now, I have this on method. It's not really doing anything. How can I make this into a listener that works with Spring Modulith? And the way that we use that is what is offered by Spring Modulith called @application module listener. And once we do that, we can see now that we can actually kick it off. Here we go. Actually, it's going to send out a lot more stuff here. And we're going to start emitting the message, and we'll see that now. We can zoom in here a little bit. And we see that we're getting some data, and we notice that it's all green, and the reason it's all green is just basically these are the creeks I'm going to go kayaking next week. So what we're going to do now is we're going to go ahead and stop that. We can actually go in and take a peek really quick at the data. And the one thing that we didn't mention before is that if you look at the Spring Modulith, it also has that starter called Spring Modulith JPA. And basically what it does is by including that starter, it's going to look and say, oh, if you decide to use the eventing structure, I'm going to go ahead and auto-configure the Spring Data Event Publishing system, And what I'm going to do is every time a message is emitted, I'm going to store it into a database table so that our messages are persistent, so that if the app goes down and then comes back up, any messages that were not processed will be processed when it picks it back up. So if we go in and we kind of do a refresh here, and we look at the JPA event publication table that Spring Module creates right out the gate, we can see that it has a customer listener or listener ID that happens to be the same name of the park service for that on method that I had, right? Also, it tells you that what type of message it was listening for, which is a stream data status, the data that was emitted, as well as the publication date, and we zoom out just a little bit more, and zoom here, the date that it was actually processed. So now we have this data, it's being emitted. We can see where it's actually being handled by our application. We can see that those messages were picked up and handled. But let's take this example to the next step. So the first thing I'm going to do is I'm going to go to I'm going to speed this up a little bit. And what we're going to do is we're going to do a get stash here. And we're going to do a get checkout name. And did I check out mine? Let's see. Yep, I did. Yay, I did. Okay. So what we're going to see now is that we're going to see that we have not just the 4 modules that we had to start off with, or sorry, the 3 modules. We're going to add in the kayaker module and as well as the research module. If we look at the kayaker module, it's going to look just like what we had before, where we had a on method. In this case, on method sends the alert, and it has the application module listener. If we look at the research module, and we see that we have a research service here, again, it has that on method that's listening for that event. And what we're going to see is a little bit different is when we run this now. Let me go ahead and see about starting that. Stop. Oop. There we go. We're going to start that. And what's going to happen now is we're going to go back in, and if we zoom in here a little bit, we'll see that we are actually going to start processing messages. And we see that we got the Withlacoochee River, and we see that they're all green. And we can, what will be interesting though, is if we stop that right there, is we can actually go in and look at our stream data and see that we are actually processing stream data. Am I hitting the right button? There we go. And we see that the data is being processed there. We can also go in and see that we are actually also getting the SMS messages. So what we're seeing is that one module called the Water Level Advisor is actually emitting events to the other modules, and they're picking it up and they're taking action with it, while the Water Advisor is actually, modules actually reaching in and making calls directly into the USGS module. Now, the one thing I want to also kind of talk about is let's see if how this looks is if I were to do some documentation. Spring Modulith offers documentation tools that will actually generate UML so that I can actually view the results of what I've told it I want to design for my given application. So if I run that test, and I'll show you what the test looks like in a second, we can see that Spring Modulith will actually render the UML. So what did that test look like? So if we take a look at the test, we see that Spring Modulith gives us something called application modules and you hand it the name of your application, and it returns back what? A list of modules. From those modules, I can hand it to the documenter, and from that documenter, I can actually what? Write the documentation out. And what it will produce is, like I showed you here, the UML that will show you the design of my module architecture, which right now I'm using what? The defaults that are provided by Spring Modulith. Also, you can dig down if you want to and view each module and get the base package, the Spring components, the events that are listened to, properties, all that good stuff, or even get the UML all the way down and view each module and see how it's constructed and what other modules it communicates with. But any test like that, documentation is cool, but how can we prove that what I've coded actually meets the requirements of what the default design is? In that case, what we can do is go to what's called module test that I've created. Again, what it does is it calls the water level applications of, gets those list of modules. And then what we can see is that it has something called, let's zoom that out. There we go. We have something called modules.verify. And this is going to verify that the code that I wrote actually uses the modules as it is defined by Spring Module to be a good pattern. We can see that it is actually green and ready to go. But who wants a green test? We want to break this thing. So how are we going to break it? Let's go up to the part module. And from the part module, what I want to do is actually break this. So how can I break it? I can actually go in. What package did we not want to use? It was what? The US stream data, right? We don't want to use that outside the USGS module. Well, guess what? I'm going to use it. So I'm going to use US stream data. And then I'm going to call it data. And now if I go back and rerun that test, what did I do wrong? Part service, did I write the right? Oh, modular structure, I ran the wrong test. There we go. Yep. There we go, this test one, there we go. Okay. All right, how did I not break that? Okay, what did I mess up? Let's go to part service. Did I put out?
You put in a different one.
Okay, so I'll put it in Kayaker service. I wrote perfect code. That's exactly what happened. USGS stream data. That should be illegal. Yeah, there we go. I put it in the right package, actually. You're right. I wrote perfect code. So what I did was I used USGS stream data in the wrong module. I put it in the Kayaker. I need to put it in the Kayaker model to get this thing to break. So what we see is I used US stream data that's in the USGS module, and it should only be in that module, but when I used it in the Kayaker module, it tells you what? Module Kayaker depends on a non-exposed type of USGS stream data within the module, USGS. So by breaking that rule is telling me about it. So now let me get rid of this.
Before, Glenn, you break this, so imagine that we are kind of migrating this application step by step, right? So we are going into this, we are migrating everything into modules. Now, is there any way that we can actually provide certain kind of information to say, Spring module, hey, can you help me out? Practically, I'm moving slowly, and I want to actually allow this particular change, right? So I think,
okay.
Let me see, Glenn.
Yep. Yes, sir.
Oh.
So that's actually a great question. The question I was going to say, or that's a great question. The question was, is there a way which we can integrate this into Eclipse? Spring Modulith is an experimental project that is planning on going full GA later this year, probably the fourth quarter. So at that time, those features will be added. So right now, it's still experimental. Please, as you start seeing things that you would like to see added to the project, add them as issues to the GitHub project. But yeah, that would be actually cool to have that. So, but finishing up, so let's go to USGS service. But the one thing that Felipe said is, how can I make that legal? Maybe I'm in the middle of a migration, and I can't do all these module changes to modules immediately. Maybe I can do it in stages. How can I maybe add behavior that's different than the defaults offered by Spring Modulith? And the way that we can do that here is by using what's called package info. And package info allows me to add decorations to the entire package of a project or for a given application. And by using that package info, what I can do is something like this. I don't want to create a new module called USGS stream. I'd rather have something that is going to give me a named interface, meaning I want to expose this package to other modules. And the way that I can do that is by exposing something called, or by adding an annotation at this package level that says named interface, and now that allows me to utilize this package in the other modules. So now if I rerun this test, guess what? I can get it will come up green because I'm saying now I want to expose it to the other modules. Now, before we go, there's a couple more things I want to show you. Is first off, what I want to be able to do is show you the original mistake that I made is I put the USGS data in a test, not the code. That's the reason why it worked perfectly before. So what I want to do here is I want to go to the park. I want to...
Can you show the UML?
Oh, gosh, yeah. So let me show you the UML. Let's rerun that documentation change here. We run it. And if we run that test right there, and we go back to the documentation, let's see where I put it right there. Now notice the change is it's been updated, and where we see we have the kayaker, the researcher, the park, and the water advisor like we had before that has a relationship to USGS, but now you see kayaker has a dependency directly on USGS just because I made that change. Now, the one thing I want to also be able to cover is how can I test these modules in isolation? What I can do, instead of using Spring Boot test, I can actually add what's called application module test. And what that means is I can actually test a module in isolation. So by doing that, you can see when I run it and we zoom in here, we can see that instead of Spring Boot test, we're running the application module test for Park in standalone. That means I'm testing this module in isolation, and by testing it in isolation, I'm not pulling in any of the other modules, so I can either mock and be able to test this in isolation, but we also see that we have just the Park here as this service. Now let me go show you, as the module being tested. So let me go down here.
Glenn, can you show that actually you can do these particular slice tests with multiple direct dependencies?
Absolutely. And the way that we do that, if we remember, the water advisor has has a direct relationship with the USGS. So for it to really be tested in an integrated way, I want to be able to bring not only in the water the water advisor, but bring in the USGS module. And the way that I do that is by still using application module test, but changing the mode to direct dependencies. And by having direct dependencies, what this means is I have the ability to pull in just those dependencies that it needs. So if I run this test, you'll see something a little different. Here we go. We'll zoom in here. There we go. Oh, sample data. Did I lose my network? Yeah, I think I did. Let's try it again. That's a great test. Let's go again. There we go. All right. So now what we can do is zoom in. And what we see is that for the water advisor, again, application module test, water advisor, I'm using direct dependencies instead of standalone. And then what we see is I bring in the module water advisor, but then you see I also have the included dependencies USGS. Now, the last thing to remember about this is that not only can you have the direct dependencies and the standalone, I also can test modules and say instead of bringing in just direct dependencies, I can say all dependencies. Bring in all the dependencies for this given test, which will pull in all the modules. So in closing, the goals of Spring Modulith is to allow you to not only to be able to declare your architecture of what you would like to have as far as your modules are concerned, but also future-proof it so as developers start working on your project in the future, that if they make changes that violate the way that you've specified the modules and the behavior of the modules, it'll catch it at unit test time. But also gives you features that you saw where we can have modules communicating each other, not only through direct service calls, but also through eventing, and then also be able to have direct ability to initialize a module at startup time, and it offers these services and a lot more. So Felipe, do you want to kind of close us out, and I'll bring up our...
Right there.
Mm-hmm. There we go. Yep. There we go. Mm-hmm. Yeah, go ahead, get started. Yep. And can you summarize that for us?
Yes.
There we go.
So very good. So remember what Glenn was telling us about the Spring Modulith is that first of all we have this convention: map modules to packages, right? So that's part of the main idea of Spring Modulith. And in this case, remember, we are talking about modules today. Now, the communication between each module will be through event listeners and events. And something that you get out of the box will be this transactional JPA. So you have that stored for further research if you want. Now, one of the cool features, I think, on this particular project is the testing. It provides you with these slices, and in this case is the application module test. And if you're familiar with the Spring Boot, probably you are using that testing, right? Like when you want to serialize, deserialize, add JSON test, or maybe you want only data, like add JPA data test. Practically, this is the same. Add application module test is going to help you to only test your single module, and as you can see, even with the direct dependencies. Of course, you can see the testing as just simple set of rules. Of course, there is architecture validation, documentation generation, and even though we didn't actually cover this today, it provides an actuator and observability support. So meaning that you can grab Zipkin, or you can use the latest micrometer and then get what is happening in each module, what is the bottleneck. So practically you have that covered. So just very quickly, an announce, we have the Spring Academy. If you put the Devnexus code, you get the 20%. Very good content. Glenn is writing all the Spring Batch piece, and there's coming more and more content to Spring Academy. So we're open for questions and answers. And here's the demo and the project. So you can take the picture.
Thank you, folks. Yes.
So from a deployment perspective, this effectively is a monolith, right?
It's what?
From a deployment perspective, this is a single application.
Yeah, and again, it doesn't, when you look at your architecture, you may not need to go all the way back to the module. Like I said, monolith. You have to also think about the goal is, can I take other services and aggregate them together based on domain? So you don't have to go quite that radical. Yep.
And do the services have to communicate with each other to create a common data source? Could it be an API, for example, or is that?
That could be an API, yes. It's an API call. Right now, it's just, you don't have to pull in that starter. You can just pull in the bits that you need, the individual dependencies, and by doing that, you'll get the same, or you'll be able to design what you want it to do. Yeah, thank you. All right, do we have a prize for folks? So if you tweeted, bring your tweet up. If you have other questions, come see me. Thank you, folks, for being here.